In this video, we're going to talk about topic 3.4, differentiating inverse trig functions. Our essential question is, how do you find, I flipped here, how do you find the derivative of an inverse trig function? And I can find the derivative of an inverse trig function. So to complete our study of differentiation in inverse functions, we now focus on taking the derivatives of the 6 inverse trigonometric functions. The key idea here is that we can use implicit differentiation to find derivatives of the inverse trig function. So before we get into example 1, I want to revisit this picture right here on the left-hand side. So a picture of a right triangle, I want to try to find the third side of the right triangle. So we would use Pythagorean theorem for that. So right now I'm just going to call this one question mark. So I know I would have question mark squared plus x squared equals 1 squared. And the goal is to solve for question mark. So I would move the x squared to the other side by subtraction. So I'd have 1 minus x squared. And then I'm going to take the square root of the question mark side. So we'd have that question mark equals the square root of 1 minus x squared. So I'm going to label that on here because we're going to need that later in the problem. All right, so we're going to consider the function y equals sine inverse of x. And we're supposed to find the derivative. So without knowing that anything else exists, the first thing we would want to do is maybe we're going to try to we're going to get rid of the sine inverse because I don't really know anything about that derivative, but I do know the derivative of sine. So we know that to get rid of sine inverse, we could take the arcs, or we could take the sine of both sides. So I'm going to take the sine of both sides, because we know that sine and sine inverse can cancel. So I have the sine of y equals x. Now I'm going to take the derivative of both sides. So I'm going to take this derivative, which I don't know that I need that notation, but we take the derivative of both sides. So we know the derivative of sine would be cosine of y. And then because we're doing this implicitly, it would be dy dx after it. Equals the derivative of x would be 1 dx dx. So we have cosine y dy dx equals 1. In order to get dy dx by itself, I'm going to move the cosine of y to the other side. So we have dy dx equals 1 over the cosine of y. And then in order to put this back in terms of x, I'm going to come over to my triangle because the triangle shows the relationships between sine, cosine, and tangent. So the cosine is going to be the adjacent over the opposite. So my adjacent is square root of 1 minus x squared. My hypotenuse is, sorry, I said opposite. I meant to say hypotenuse. It's the adjacent over the hypotenuse. Hypotenuse is 1. I really don't need that 1 in the denominator. So you'll see that my derivative is 1 over the square root of 1 minus x squared. So the good news is that there are formulas for each one of these. We actually just proved this formula here, which if you look at this one here is exactly this formula here. So the reason there's 2 charts is there's one that's just the basic chart. Hey, here's what happens when you take the derivative with x. And you'll notice that there's patterns. Arc sine and arc cosine are identical except for there's a negative in front. Arc tangent, cotangent identical except there's a negative in front. And same thing with arc secant and arc cosecant, there's a negative in front. So all the ones that start with a C, you put a negative in front. And then the arc sine is square root of 1 minus x squared. Arc tangent is 1 plus x squared. And arc secant is 1 over absolute value of square root of x squared minus 1. So the difference in the tables is this first table shows what happens with the chain rule, because we know we always have to take that into account. So they're saying like u is the inner function, and then that makes sure you always take the derivative of the inner function. So, and if you look at the derivatives on the inside cover of your book, you would notice that here. All right. So we can either go the long way like we did with example 1, or we can go the short way and just apply the formula. On the actual AP test, you're probably going to see mostly arcsines and arctangents. The rest of them aren't as common. You most likely will not see very many of the ones that start with the letter C.